Alright, so I think we're recording here. Let's take a look at this daylight problem. In Sunnydale, the longest day of the year, June 21st, has approximately 16 hours and 15 minutes of daylight. The shortest day, December 21st, has about 7 hours and 45 minutes of daylight, and the vernal equinox has about 12 hours of daylight. Assuming the sinusoidal model for the number of hours of daylight, find an equation that gives the number of minutes of daylight in Sunnydale as a function of the day of the year. Alright, so let's work in minutes. So 16 hours and 15 minutes. 16 hours. Let's take 16 times 60 and then add 15 to our maximum in minutes of 975. So our 975 minutes is our max. Um, the minimum is 7 hours. 7 times 60 plus 45, 465 plus 975 divided by 2, 720. So this is minutes. It's hard to read that. Minutes. So this center line is yeah, 12 hours. Okay. So what day of the year is June 21st? Or we could start with March 21st. If this is March 21st, then we can do that. Right. As a function of the day of the year. So January, February, March. Assume a non-leap year. And then we're only going to March 21st. So, would it be right to say that 31 plus 28 plus 21, 80? That this March 21st is the 80th day of the year, and that would put us at a starting point there. Now let's just assume that the period is until we get to the next, March 20. We'll ignore leap years and stuff like that. So if we take 365 divided by 4, 91.25. So yeah, let's go with this. Okay, so we've got this function of that's going to tell us the number of minutes. No, the output is minutes, and our input is the day of the year. Our amplitude, what is 975 minus 720? 255. And we'll assume the period is a year, and a shift to the right, we actually subtract, and our center line is at 720. So 2 and 365 are, I can't reduce that. Yeah, this is the, well, now if my input is D, the day of the year. There you go, that's the equation I would use. Hey, I hope that helps, and I'll talk to you later. Bye.